But like you don't really need to come for that last, like when it comes to the final exam, because I'm not going to give you anything for that day. So, all right, let's take a look at number 4. Okay, so just like we've done before, we're going to start by reading the question. We're going to underline the important information. We're going to write the formula for whatever the shape is, and then we're going to plug in the information that we know. So that's always going to be what you do. Underline important information, write the formula, plug in what you know. If you've already done number 4, then you're just checking your number 4 with me. All right. Number 4 says, as phosphate is mined, it moves along a conveyor belt, falling off the end of the belt into the shape of a right cylinder cone as shown. A shorter conveyor belt also has phosphate falling off the end into the shape of a right cylinder cone. The height of the second pile of phosphate is 3.6 feet shorter than the height of the first. The volume of both piles is the same. To the nearest tenth of a foot, what is the diameter of the second pile of phosphate? Ooh, there's a lot of stuff happening there. And I tell you right now, this is a straight up question from the EOC like 2 years ago. I stole it. This was a real question on the test. So, what is the first piece of information you see is important that you want to underline? What's important in that? Daniel, what's important? It's a right circular cone. Good, that's important. A cone. So we should already be thinking cone formula, cone formula. Okay. What else is important? Okay. There are 2 cones and the volume of both is the same. So whatever you have for one, it better be exactly the same for the second one. Good. What else is important? Good. The height of the second pile is 3.6 feet shorter than the height of the first. If it's 3.6 feet shorter, what does that mean you're going to do?
Subtract 3.6 from the height
of the first one. Yeah, good. So shorter means you're going to subtract. Good. Is there anything else that's important? Just one more important thing. Boom. That's what's important. You're finding the diameter. What is the diameter? Right? That's what I'm trying to find. All right. So we know we have 2 piles of phosphate. They are both in the shape of right circular cones. I give you the first pile of phosphate. You're not given a picture for the second one, but that's okay. You know that both piles have the same volume, and you know that the height of the second pile is 3.6 feet shorter than the first. You're trying to find the diameter. All right, so you already know some information, and you've got some things you're trying to find. Now, no right or wrong answer. What do you think we should do first? Daniel, what do you think?
I feel like we should add 8.6 back.
Oh, beautiful. Okay, cool. First thing Daniel sees is, hey, look, there's a picture of a cone. And he notices that 48.6 is the diameter. He knows he's going to have to figure out what the radius is because we're going to need to use the radius in the equation. So you said to do what with that number? Divide it by 2. Good, to get my radius. All right. So diameter is 4.8. What's the radius? What's half of 48.6? 24.3. Good. That was a great first step. We found the radius of that cone. What else do you see is labeled in that cone for you? The height. And the height is right here. It's 15.3. Don't let it freak you out that it's off to the side. It's still the height. This is the height. All right, beautiful. So you've got the height, you've got the radius, you know it's a cone. What are you going to do now? Plug it into what formula? The volume cone formula. Exactly. So let's find the volume of this cone. Now, I'm going to label this as, this is the first one. This is the original pile of phosphate. So when I go to find the volume, I'm going to label it as volume of the first, just so I remember, hey, this is the first pile. It's the original pile. Okay. Volume of the first. Okay. So a cone formula, it's up on the board, but it's also the same as a cylinder. It's just divided by 3. So I know a cylinder is pi r squared h. And a cone is I just take that whole thing and divide it by 3. So all this is about to be is a plug and chug. We're going to plug in the radius, which we have. We're going to plug in the height, which we have. And then our calculator is going to do the work for us. So pi times 24.3 squared times the height is 15.3, and I'm going to divide that whole thing by 3. All right, so like I said, it's just a problem for your calculator. Now, I don't care if you've already done it, do it again. Everybody put that into your calculator. Let's see what we get. Let's make sure we remember how to use it, and make sure you're using the black calculator, not your phone. All right, give it a second. Go ahead and plug that in. Go straight across. All righty. Who can give me what number they got? What kind of number did you get? Hopefully a big one.
For the full answer?
Full answer.
9,460.
Beautiful. Yeah, man. Okay, now, before you write it down, actually, before we do anything, first of all, how many of you did not get that? Tell me now, because if you don't know how to use the calculator, then we got a problem. What did you get? Did you get 20 something? 28,000? Something like that? Okay. You forgot to do, you did everything on the top. You forgot to divide by 3.
Oh.
Divide it by 3 and then tell me what you get. Thanks, Rita.
Okay.
Is that what you got now this time?
Yeah.
Yeah, okay, good. Anybody else not get that number? It's okay if you didn't, but tell me now, what'd you get? 5,000. My assumption is you probably did not square your 24.3. So try it again. Thank you. So if you're putting in the calculator, you put pi times 24.3 squared times 15.3 equals. You should get 2838.2, and then divide that number by 3. Divide that number by 3. You're not done yet, Marissa. Divide that number by 3. And that'll give you your answer. All right. Now, when we go to write this down, here's my suggestion. I know that the question is going to ask me to round to the nearest 10th. However, if you start rounding now, and you round to the 10th now, you're going to round, and then you're going to round again, and then you're going to round a third time, and by the time you get to your final answer, you're going to be off because you rounded so many times. So here's my suggestion. When it comes to problems, always, no matter what it asks for, write down 3 decimal places afterwards, always. And don't round until the very end. Because if you continue to round, you're going to be off a little bit and then your answer is going to be wrong. Okay? So don't round till the end. So for right this moment, I'm going to write my volume as 9460 point, and again, every time, they're never going to ask you to round to 3 decimal places. Never. There's like no chance of that. So if you round to 3 decimal places now, by the end, you could always make it shorter, but you can't make it longer. Does that make sense? Right, you can always take numbers off, but you can't add numbers to it. So round to 3 decimal places every time. 903. Okay. And that is in feet, what? Cubed, because it's a volume. So my volume of this first cone is 9,460.903 feet cubed. Woohoo! Okay, you did the first part. You found the volume. Good job. You're still definitely not done though. Because what are you trying to find? The diameter of the second pile. So this is the first pile. The second pile is also in the shape of a right circular cone. So again, pile 2, second pile, is also a cone. So what equation are you going to use for the second pile? Yeah, you're going to use the exact same equation. Volume equals pi r squared h divided by 3. So let's write it down. I'm going to put second. Volume of the second, again, is pi r squared h divided by 3. And we have to plug in the information that we know. Now, what information do you know about the second cone? What is? The height of the second pile is 3.6 feet shorter. So if it's shorter, I'm subtracting. What was the height of the first one? 15.3. So to find my height of the second one, I'm going to take 15.3 and subtract 3.6. So 15.3 minus 3.6. That's going to give me my new height that I'm going to plug in because it's shorter. Shorter means you subtract. So 15.3 minus 3.6 is 11.7. So I know the height of my second pile is 11.7. Beautiful. What else do you know about your second pile? The volume of the pile is the same. So what's the volume of your second pile? Yep, it's the exact same one as right here, 9,460.903. Great. So you've got the height and you've got the volume. What are you going to find? You're going to find the diameter, but what are you going to have to find first? The radius. Good. So now what we're going to do is we're going to substitute. We're going to plug in our answers. So now let's plug these in. Plug in. All right, so here's my equation. Volume equals, so my volume is this number right here, 9,460.903 equals, I've got the pi. I don't know the radius, so I leave it as r squared. I know my height. What's my height of the second pile? 11.7, that's what we found. And then I take that whole thing and I divide it by 3. So I plugged in my answers. This is my equation. And now it's an algebra problem. Okay. So I need to get everything from the right side over here that's not the r to move over to the left side. That means I have to move over the pi, the 11.7, and the 3. Everything's got to go from the left to the right. and I'm going to move it by undoing everything on the right side. So if it's addition, I would undo it with subtraction. If it's multiplication, I would undo it with division. If it's, well, that's it, right? You just undo it using whatever it is. So every number over here has got to move over to the left side. Now you got a lot of choices of, excuse me, of ways you can do that. There's no right or wrong answer right now. Which one do you want to move first? Which one? Again, no right or wrong answer. Beautiful. Dale makes a good point. Let's get rid of divided by 3 because fractions are fun. Let's get rid of them. Don't like them. Let's be done with them. So this is divide by 3. To get rid of divided by 3, I would multiply by 3. Whatever I do on one side of the equation, I have to do the other. So since I multiplied on the right by 3, I'm going to multiply on the left by 3. And it's going to be a very big number. Times 3. Okay. On the left, it is, this is large, 28,382.709. Okay, and then what happens on the right side? Yep. Well, so if I multiply everything by 3, I then have to divide by 3. Right, and David said that. You just cancel the 3's out. So all you're left with is what's on the numerator of the fraction. So what's left at the top of the fraction? Pi r squared times 11.7. So I just rewrite that. Pi r squared times 11.7. Okay, good. So you've gotten rid of the divide by 3. I still need to get everything on the right side that's not the r over to the left side. Again, no right or wrong answer. What do you want to move now? Or what do you want to do now? Okay, that's a choice. We could combine some like terms. We could multiply pi times 11.7 and get a number. That's a choice. What's another choice of things you could do? What do you mean put it in half? Well, do you see any 2's over here to divide by? No, so I can't divide by 2. What's happening up top? Pi r squared 11.7. What am I doing with all these numbers? I'm multiplying them all. So how could I undo it? I could divide. So if you wanted to, you could divide by one of the numbers that's not r squared. Or we could do what David said, and we can combine some like terms on the right. It's up to you. There's no right or wrong answer. There's a lot of different ways to do the problem. Let's combine like terms because that's what he said to do. So let's multiply pi times 11.7. Do that in your calculator. Tell me what you get. Yes. Did you what? I don't believe so. Why? I didn't see anything, no. All right, we're going to round 3 decimal places. So what did you get when you did pi times 11.7? Ooh. I got 36.75. What should I round that to? A 7. So if I multiply those two, you get 36.757, and then I still have to bring down times r squared. All right, we're getting there. We're close. We're close. I still got to get that r by itself. What do I have to do? Yeah, divide by the 36. And for whatever reason, The other day when people were doing these problems, they subtracted the 36. I'm not quite sure why they did that, but this is multiplication. So to undo multiplication, I have to divide. Okay, divide by both. 36.7. Okay, plug that into your calculators. You get r squared equals some number. 2, 709. Okay, what did you get for your r squared value? 772.172. And I would just keep that number in your calculator. Don't get rid of it. Just leave it as the exact number that it is. And then what's my final step to get r by itself? Because r is not by itself. Square root it. Yes, the opposite of squaring something is to square root. Do you remember how to put that in on your calculators? So if you keep the number 772.172 in your calculator, to square root, it's right above the squared button. So you're going to push shift and then x squared. Shift x squared. Shift x squared. You get 27.78797, blah, 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 blah. Yeah? Shift x squared. All right, so my radius, leave that number in your calculator. My radius is 27.788. I'm just leaving it in my calculator though. And that's fantastic. Am I done? No, I'm not. It asks me for the diameter. It doesn't ask me for the radius. So you found the radius. What do I have to do to find the diameter? Multiply the radius times 2. Good. So 2 times the radius is equal to the diameter. All right. So I'm going to multiply this by 2. So again, if you just leave it in your calculator, what do you get? So put it in your calculator. What do you get? Anyone? .55. You can put 576. So your diameter is 55.576. And then what does it ask you to now, since you're at the very end, now we're going to round. What does it ask you to round to? 1/10 of a foot. What does that mean? 1 decimal place. So your final diameter is what? 55.6. And we're talking about feet. There's your final answer. Oh my gosh. That was quite a doozy of a problem. And I'm telling you right now, like I said, I stole that problem from the EOC from a year ago. So those are the types of problems they're going to be asking you. Now, when you go to input it, your test is on the computer. When you go to put your answer in the computer, now, I don't know, they might give it to you like this, as kind of like a Scantron where you have to click the buttons for it. They might also give it to you just as a whole bunch of boxes. And in each box, you have to type your final answer. So when you go to type your answer, each number gets its own box, and then the decimal place also gets its own box. So when you go to plug it into your computer and type it in, 55, each one of those gets its own box, the decimal gets its own box, and then you put the 6. And then if it asks you to fill it in, it might actually ask you to fill in the numbers, bless you. You can fill them in. All right. Notice though that the diameter is 55.6. Notice that they give you extra boxes. That's fine. Don't use up the extra boxes. If you don't need them, don't use them. Only use what you need. They'll give you more than what you need. They're going to help you start adding weird numbers to it or do something strange, add zeros or something. If you don't need it, don't put anything in the box. Okay, only use what you need. Leave the rest blank. And always work from left to right, because I'm pretty sure if you leave the first 3 blank and then you put 55.6, I think they mark it wrong. Okay, so make sure you just start from the left, put your answer in, leave the rest blank that you don't need. Okay, all right. Can I answer questions on that problem? I know it was a long problem. Okay, so I'm going to leave it on the board. We've got about 20-ish minutes. That's why we have 16 minutes left. And so for the last 16, I want you to work on the remainder of the problems that you haven't finished yet. So if you have more problems to do, you're going to take the time right now to do them. If you've already done all the problems, then you're going to get your butt up. You're going to go to the front of the room and you're going to check your work with mine on the board. So on the board, you will see I've got my answer key up there. I've got the questions written out as best as I can, and I've got all my work shown to the best of my ability. Here's the front side, here's the back side. Okay? So you can come up, you can check the work when you're done. Or if you just want to see if you're going on the right path, you can get up now and go check your work. You don't have to ask me. You can just walk up there and go check your work. The expectation is, though, that by tomorrow, you've got all the problems completed and you've got all of your answers checked. Okay? Questions? Then you've got the remainder of the class period to either complete your work or go get your butt up and go check your work.